Are we ready? Okay, let's get started. The wave for this event is at bit.ly/appengine2, and the moderator gadget inside the wave is a great place for you to post questions as they come to you. We'll make sure we visit the moderator at the end of the session and answer all the questions that are there, so please take advantage of it. Excuse me. We did this crazy thing. We took a whole bunch of corporate applications, the kind of things an enterprise would never think about running anywhere except in their own data center, and we wrote them and run them on App Engine. We're here today to tell you how we did it so you can do it too. I'm Ben Fried. I'm Google's CIO. I'm here with Justin, Matt, and Irwin, and we're going to talk to you more about this. So IT at Google, for us, we think of ourselves as Google's pit crew. We're the people who do the engineering that runs the business of Google. And the way that we do that, our goal in doing this, is to use exactly the same tools like App Engine, for example, that you all came to I/O to learn about. The goal that we have, the mission for the organization, is to have Google itself as an enterprise run completely in the cloud. Excuse me. You're the crowd. We're the cloud. So let's find out a little bit about you all. How many of you have done anything with App Engine before, written anything, tried it out, using it right now? Awesome. Awesome. That's great. That's a lot of hands for all you on YouTube. How many of you are curious about using App Engine for your organizations, your businesses? Excellent. All right. You're in the right place. And just as a spot check, how many of you came here because you heard we'd be giving out T-shirts at the end? All right. So it's really us who are selling. That's good. That's great. So what is the what? Our supposition, which proves to have been correct, was that you're here because you want to understand how you can write and run applications for your businesses, for your organizations, that run on App Engine in the Google Cloud. So great, that's what we're here to tell you about. As Google CIO, I feel an obligation to step back a little bit and make sure we're all on the same page about why this is a good idea and something that you'd want to do for your organizations. So, kind of the nightmare side of every CIO's life is the fact that the stuff that we do, the IT that gets valued by our users, is like the part of the iceberg that's above the water. But the reality of it is, in order to do that stuff that people can actually see and touch and experience, we have to make an enormous effort and investment in all this technology that's below the waterline. This is the stuff that our end users never directly interact with and never actually they only care about it when it doesn't work, right? That stuff only exists to enable the technology that makes our organizations better in some way. But the problem is that I think the stat I heard at the keynote was you can spend up to 60% of your IT spend actually engaged in just operating your environment. And all that is a distraction of every sort from what you really should be doing, which is building technology that matters to your company, that makes a difference to your company, and delivering the technology to the people in your company. Now, part one of the problem is, of course, you have to support hardware. You need hardware to do this, right? That means you need servers and storage and networks and data centers and guys in fuchsia-colored shirts who probably went to Caltech to run all that stuff for you so you can have a place to run your apps, right? And this is problem number one. The hardware environment that you need to invest in order to run your own apps is really expensive. And ultimately, it's not, again, what your IT department is about. What your IT department is about is all the stuff that this stuff enables. So by way of comparison, let's talk about what App Engine offers that changes the game here. So this is a picture of a Google data center, and that's Larry Heffley, who's a Google data center operations technician, who's been with the company for some time. And a picture actually tells 1,000 words. So you might have to look into this picture a little bit to understand the differences. Larry's in a Google data center, and if you'll notice and look closely, you'll see that the servers that surround him don't look like the servers that are probably in your company. Google, fundamentally, part one of the value proposition of App Engine in the Google Cloud is that Google presents a unique economy of scale that we can share with you through App Engine. And to give you an example of what that economy of scale is, it's cost effective for Google to actually design and build its own servers. These are Google servers that actually have batteries attached to them for power purposes, but we have teams that design and build servers for us. That makes sense. We get great cost efficiencies out of doing that. Then on top of that, we design custom data centers to house these servers, right? And because of the unique relationship between the Google servers and the software that runs on those Google servers and the Google data centers, we're able to achieve industry-leading power utilization efficiency numbers for these data centers as a result. Finally, on top of that, because these data centers are so big, we can put them in places where we can get the cheapest possible power. As a case in point, I mean, it makes sense for us to go and find fully depreciated hydroelectric dams as places where we want to plop down one of these massive data centers. You know, there's only a handful of organizations in the world that are ever going to have these opportunities and these kinds of economies of scale. And the first element of what's great about App Engine and why you should all be interested in it, or if you're not CIOs, why your CIOs should be interested in it, is that App Engine is, you know, all clouds are not created equal. App Engine is a vehicle for you to tap into these unique economies of scale that Google and very few others have. But it's not just about the hardware and doing hardware and all the stuff that runs that hardware cheaper. The great point of App Engine is that it's a platform, it's a web runtime. And what that means is when you write apps that run on App Engine, there's a whole bunch of platform issues you don't have to make an investment in that you get for free just by writing to the App Engine APIs, right? The stuff on this stack of library books is incredibly important for every organization to do to deliver technology. But these things themselves don't make an organization great, right? These are part of a platform for applications that make your organization great. And what's so cool about App Engine is you get all this stuff for free. You have to make no conceptual investment in these sorts of areas of technology in order to deliver great applications to your company. So part one of the App Engine advantage is unique economies of scale on the hardware side, and part two is you're buying into an entire platform. And the virtue of that platform is there's a whole set of systems activities you don't have to be concerned with anymore, and you don't have to dilute your focus from delivering applications that make your company better. So there's a better way, and it's based on running in the cloud and running on App Engine. But in order to take advantage of this, you can't just build applications exactly the way you were before, right? It's not easy to make this transition. Making a transition, I think any organization that wasn't started today has the problem that they've got a bunch of stuff in their data centers running their companies already. Google has exactly these same problems. We're just like all of you in that regard. We've got a bunch of the same business concerns that every organization has. We've got a bunch of corporate data centers that host applications that were written kind of in the age before there was an App Engine. And figuring out how to make this transition, how to move to being a cloud-based enterprise is hard when so many of your key assets, whether they be software or services or whatever, are still inside your data center. So that's the transition is point number one about what makes this hard. And point number two about what makes this hard is that although App Engine is great because you're using familiar tools and languages that we all know and love, like Python and Java, you can't write your applications in exactly the same way. Part of the platform requires you to make some coding changes. And this stuff isn't necessarily obvious. There aren't a lot of footprints to be followed for enterprises in making this transition. But we figured it out. This is part of our organization's mission, is to do this and share it with you. And we're here to do that right now. And so with that, I'm going to introduce the first of the three development teams, the first of the three corporate engineers and development teams, who are going to talk about how we did this for some applications that run the business of Google today. First up is Justin, who's here to talk about AppReduce.
Thanks, Ben. Hello, everyone. I'm Justin McWilliams, one of two engineers that built AppReduce. So by show of hands, how many of you have licensed software on your corporate workstations? So as expected, a lot of you. And how many of you at some point have realized that you no longer needed a piece of licensed software, or maybe even forgotten that it was installed in the first place? Again, a lot of you. So lastly, how many of your companies attempt to reclaim unused software licenses? I see a couple of hands here and there. Okay, so that's exactly what AppReduce addresses. And we do this by providing transparency to our employees around the software licenses that are in use by their computers. So you can see here, we provide them with overall cost of their computer, compare that to the average Googler and the average Googler in their department maybe. And then down below, a quick list of the software that's installed in their computer, associated licensing costs, and an uninstall button. So when this uninstall button is clicked, we actually make a call back to a corporate inventory service that automatically uninstalls that application from their computer. And I'll go into a little bit more detail about how that works later. So how did we build AppReduce? Well, initially we designed and developed for a traditional LAMP stack, where we basically had an Apache server, and when the user visited the site, we would directly connect to 4 or 5 databases and APIs on the fly, pull down all of the application data, loop over it, do regular expression matching for licenses, do some cost calculation, all this stuff on the fly, and then present the page to the user. So we decided to port to App Engine for many of the reasons that Ben mentioned, and we found that we could use the same frameworks that we're familiar with in the LAMP stack. So AppReduce is built with Django and Python. We use Google Closure JavaScript library for much of our front-end and UI elements, and the Chart API for various reports, one of which you saw on the first slide, and Google Analytics for usage tracking. So in porting to App Engine, we did encounter some challenges, however, and one of them is fairly obvious. How do we get at this data that's residing in our corporate network from App Engine? And the answer here is Secure Data Connector. So Secure Data Connector is a way to create a secure tunnel from App Engine or out in the cloud, anywhere in the cloud, to make HTTP calls back into your corporate network to whitelisted URLs. So a good example of where we use this was to access our Remedy Help Desk ticketing system API, which was pre-existing. So we were able to file tickets from AppReduce. Googlers could report inaccurate inventory data or ask questions about a particular license or open source alternatives, things like this. So you might ask, what about non-HTTP services? And the answer is to write an HTTP wrapper around that service. And one example of this was for Microsoft System Center Configuration Manager, formerly known as System Management Server, which is a corporate inventory system built by Microsoft. So we wrote an HTTP wrapper around this service, so when users click that uninstall button that you saw, we would make an HTTP call through SDC into our HTTP wrapper, which would then translate that call to Windows Management Instrumentation to interface with SCCM or SMS to push out that uninstaller to the machine. So the next challenge was real-time user performance. If you remember back on the LAMP slide that I showed you, I mentioned that we were directly connecting to all of these databases and APIs on the fly. And we found that when moving to App Engine, this was providing for a suboptimal user experience due to the fact that your backends and your databases are inside of your corporate network, and the App Engine front ends may be somewhere else out in the internet, so there's added latency. So to get around this, we actually ended up caching a lot of our corporate data in the cloud using bulk loader. So we have code that runs in our corporate network that fetches the same data on a regular basis, does all of the aggregation and the cost calculation and license matching up front, and then hands it off over to bulk loader to shovel up into App Engine's data store. So we're actually using this to push about 75,000 rows of data 3 times per day, and it's been really great for us. Bulk loader handles like automatic error retrying. It handles throttling, threading. It's really just, it's a great way to get data from your corporate network up into the cloud. So here's an overall design of AppReduce, and a lot of this should be familiar. You'll see the corporate network on the right-hand side with all of your inventory systems and services, and App Engine and AppReduce on the left-hand side. Secure Data Connector and bulk loader bridging the gap between the two of those. And again, as mentioned, when the user visits the AppReduce front end, all of this data is going to be loaded from the local data store. And we even have a Memcache layer in between there to reduce redundant hits on the data store. The new piece here is the section up top, the GAE, cron, and task queue. So task queues are a way to run code in the background on App Engine, sort of independent from the user's interaction with the site. And we use this for various reasons, but I'll give you a couple of examples. So first off, status emails. We send Googlers emails on a regular basis, reminding them of AppReduce, reminding them of the licenses they have on their machine, and asking them to come uninstall applications that they no longer need. Another example is uninstallation verification. So on a regular basis, we're checking to make sure that when that uninstall button is clicked, those applications are actually being uninstalled by the inventory systems. And if not, then we can raise flags and email the administrators of those systems so they can have a look and see why it's not working. So all in all, we found that putting information into Googlers' hands can be very powerful, and transparency at Google is well received in general. To date, we've saved over $450,000 by recycling licenses, and within 24 hours of launch, we actually had over $150,000 worth of savings, which, by the way, we had QPS spikes up to 50, and sustained 20 QPS for several hours after launch. We totally did not expect adoption like this up front due to the corporate nature of this application, but App Engine handled it quite well for us, so that was a pleasant surprise. So it's also worth mentioning that AppReduce was built, released, and supported by only 2 engineers, myself and one other. And I think this is a good testament of what it takes to build something like this in the cloud on App Engine. You don't really need a team of 10 or 20 people. And lastly, about 2 weeks after we launched AppReduce, myself and the other engineer were actually allocated on other projects, and AppReduce kept on chugging along by itself. We didn't really have to worry about it. The App Engine platform took care of things like server uptime and monitoring and all those sorts of things that a normal developer would have to handle themselves. So I think this is our experience with building an application in the cloud that requires corporate inventory systems and data that's behind your corporate network. And this is a theme that I think you'll see in the next presentation. Please welcome Matthew Simmons with the Techstop Online project.
Thank you, Justin. Thank you all for being here. Welcome. As Justin said, my name is Matthew Simmons. The project I work on is Techstop Online. I'm one of the developers that work on that. So what is Techstop Online? Well, Techstop Online is where we keep all of our internal IT support documentation that we use to support our users. Its namesake actually tells you a little bit about what Techstop Online is. Techstops are rooms in each Google office where you can go to get fast, friendly, efficient IT support. We aim to be the online equivalent of that. In essence, you can think of it like a CMS or a content management system. We provide a lot of the same features, and we have a lot of the same requirements. Previously, we were deployed in a managed LAMP environment using an OSS CMS solution. And we migrated to App Engine for a variety of reasons, many of which Ben covered, and some of which I will cover in a second. Like AppReduce, we deployed using the Django framework on App Engine and the Google Closure JavaScript library. We make use of a lot of the same technologies, secure data connector, task queue, bulk loader. So I mentioned that we had some motivations for moving on to App Engine. Primarily, I'm going to cover scalability, which was one of the places where we saw the greatest benefit. I'm also going to cover some of the challenges we encountered moving to App Engine, some of the shifts in development paradigm that we had to accommodate. And I'm going to close out with a couple of tips that we found to be useful. So I mentioned scalability. I kind of think of it as bursty demand. These graphs are going to look pretty familiar to anyone who runs web applications. On one side, you're going to have your normal periodic demand on your application. For us, as a support documentation thing, this is your weekly demand spike with weekdays high, weekends low, and represents things like users saying, coffee plus keyboard equals bad. Tell me how to get a new keyboard. And on the other side, you have a sudden surge in demand for a single thing. And again, that's going to vary by what application we're talking about. For us, it could be we change our remote access policy, and the night before, everyone needs to get the documentation to see how to install the new remote access software. That's when the documentation system is the most valuable. It's when it's under the most load. It's also when it's the most brittle traditionally. It's the most likely to break, which is bad because everyone needs the same information, and the fallback are people sitting in the tech stops, and they don't parallelize as well as documentation does. So we did handle scalability when we were deployed in a different environment. The challenge we faced was it took a lot of our attention. We had to devote a lot of cycles to dealing with these scalability concerns. We were kind of having to allocate development cycles to platform concerns instead of devoting them to actually making the application better, things that we wanted to deliver on for our users. So when we moved to App Engine, we were really pleasantly surprised to find that we stopped having to really devote a lot of thought to how we make sure our app scales. It freed up a lot of cycles. It allowed us to address a lot of these application level concerns that we wanted to address. What were some of those? Well, our philosophy is that you can have the best, most accurate support documentation in the world. It can be the most appropriate for the problem at hand, but if the user can't find it, it's worthless. So navigation, specifically in this case search, was one of the first things that we looked at. So what we found was that because we implemented our article content with App Engine text properties, and at the time they weren't indexed, we didn't have a quick, convenient way to search within the article content and return a specific article within the App Engine framework. This is a problem that we decided that we needed to tackle ourselves. We had a couple of approaches. The first approach was we decided to try and do information retrieval ourselves. We stripped the HTML, we tokenized it, we built indexes, we did all that jazz. We did it all in App Engine and it worked. But then we got to thinking, we're spending a lot of time trying to implement search here. Maybe at a big company like this, someone has tackled the search problem before. Maybe we can work off of someone else's work. Well, it turns out someone at Google has thought about search before, and we were able to use the Google Search appliance that sits in our corporate network to index our help support documentation. We again encountered a challenge. That challenge being that our documentation repository was now in the cloud, and our Google Search appliance was on our corporate network, and a firewall lay betwixt. This is where we use the SDC, and you heard Justin talk a little bit about the SDC earlier, the Secure Data Connector. We found it to be a great way to communicate and to leverage these resources that we already had in our corporate environment and sort of get a lot of efficiency out of things that work that had already been done. Additionally, SDC is really easy to use, or we found it really easy to use. This is an example call to SDC. If you take away the highlighted part, it looks just like a URL fetch. The resource in question happens to be behind the corporate firewall and would otherwise be denied. But by adding this headers use intranet yes, you've turned it into an SDC call. Really, we found it to be a fantastic solution. The next thing we went after was, again, along the navigation theme, was tackling what happened if a user didn't get the perfect document on the first hit of their search results, or if they clicked on a search result and it wasn't the right one. We wanted to provide them a link to what they were really looking for on the page, so we wanted a recommendation system. We decided to implement it using similarity calculations, and that's kind of all beside the point. The point is that all of those calculations took a really long time to run. And every time you add a new article in a CMS, you would have to rebuild this similarity index. So this is a very long-running task. It would almost always run longer than the 30-second request-response cycle allowed. What we found is we could use the task queue, the App Engine task queue functionality, to not only, technological failure. There we go. Not only get the job done, because we could split it up and defer it and run these similarity calculations asynchronously, which is what task queue does fantastically, but it also got it out of the way of the user, right? So an article author finishes, they submit their article, and we have to figure out the similarity, but they don't need to wait while that happens. So task queue's ability to get the task out, or the technology out of the way of the task, we really enjoyed as well. Now, when I think about database design, my first reaction is to think in terms of relational database systems. So I start thinking about normalization, I start thinking about which normal form, et cetera. This was a shift for us. App Engine works really well with a denormalized data schema. So we eventually came around to not thinking about normalization as much, and it worked out really well for us. That's not saying that you can't have links between entities. You can. You can use the App Engine reference property. One of the things that we encountered while using the reference property is that every time you access an attribute that's a reference property, it'll fire an RPC to data store to pull the referenced entity in. If you're iterating over a set of entities that have reference properties, and you want to access something on the referenced entity, you're going to be throwing a RPC to retrieve that in every part of the loop. That can lead to some issues. What we found is it's really efficient to figure out what you're going to want and to cache it, to take that piece of data and programmatically cache it on the entity you're iterating over. That, for our application, solved some of the problems that we were having, and it's a very good thing to keep in mind. Another thing that we found, another advantage of developing on App Engine is, as a small team, and we are a fairly small team, maintaining a test instance was a significant amount of work, more work than we wanted it to be. We had to spin up a separate environment, and then we had to keep it roughly representative of the production environment. So when we were testing new changes, we were actually testing it against something that represented the real environment. With App Engine, one of the approaches that we found to be useful was to register a second application with a slightly different name. In our case, we would append -QA, quality assurance instance. You could use anything, really. But the idea is that you would push out, when you push to your production instance, to this other instance that you have registered at the same time. And now you have the same code base on two App Engine apps, and you have sort of a baked-in test environment. On top of that, we had multiple people in the team that were testing multiple different functionalities. We found that the version string for each app was a great way to give each developer their own little sandbox to test their own feature changes. So in summary, we found App Engine for TSOL, or Techstop Online, to be scalable by default. The ability to fetch corporate data with the SDC was a great boon. Deferring expensive jobs to the task queue was essential in making Techstop Online work the way we wanted it to. And then learning about data store denormalization and setting up a test instance really helped us sort of iterate away and create great applications. And with that, I'm going to hand it over to Irwin.
Thanks, Matt. Hi, my name is Irwin, and I'm one of the two engineers who built CloudCourse. During this presentation, which is going to be a bit more technical, we'll go quickly over what CloudCourse is. Then we'll look at the challenges we faced building this application and how we address those challenges. So what is CloudCourse? CloudCourse is a course scheduling system. So basically, it's a platform which allows people who want to teach a particular course to reach out to people who want to learn about it. Say, for example, I want to teach a Python 101 class. I would go into the system, create a new activity, Python 101, and then I would schedule some sessions. I'm going to teach it in New York City on Monday, in Mountain View on Friday, and over webcast also. I'm going to add some constraints to this. I don't want more than 10 people to sign up for my class. At some point later, someone would go into the system and make a search, say, all right, I want to learn about Python. Tell me what you have next month in San Francisco. And then we're going to return a list of sessions available. Some of them are going to be open. People can sign up. Some of them are going to be full, and the user is going to be waitlisted. That's, in a nutshell, what CloudCourse is, course scheduling system. How did we do it? Well, surprise, surprise, App Engine and Python. For the front end, we use the Django web framework and the Clojure JavaScript library. And we use GData to do calendar updates. So when a user signs up on CloudCourse, we automatically update their calendars. All right, now the fun part, our challenges. An application like CloudCourse is inherently very relational. How do we deal with the fact that we don't have joins? Second one, long-running computation. There's a lot of things we have to do which are going to take some time. Say, for example, you have a session with 10 people enrolled and 10 people waitlisted. Someone is going to drop out from that particular class. We have to reprocess the waitlisted people. And when doing so, we need to send emails, we need to update calendars, get user permissions, and whatnot. And this takes time. How do we deal with this long-running computation? And finally, we'll go into details on how we managed to build a high-performance transactional system, and we'll look at what we mean exactly. So let's start with the first one, no joins. This is how a co-scheduling system would look in a relational database, your regular SQL stack. You have an activity table and a session table. It's a one-to-many relationship between the activity and the sessions. Now, when a user goes into the system and says, all right, give me all the Python sessions you have available in June in San Francisco, we need to do a join between the activity table and the session table. And this is because of this name on the activity. Now we don't have joins. So how do you deal when you don't have joins? Well, what about we merge everything in one table so there's nothing to join on? You have one table. We can do this. We have the name of the activity. The sessions, we're going to serialize them in a list as binary blobs. And then we look at the query that we need to do. The query is about finding the sessions of interest for a particular date and location. So we need to be able to index on those pairs of date and location. One easy way to do this is to put those pairs in a list. And this list is going to be automatically indexed by data store. So now when I run a query, I'm going to be able to do an index lookup on this table. That works, but that comes with some limitations if you take this simple approach. One is exploding indices. You cannot have more than 30, 100 indices in data store. So depending on how many pairs of date and location you have, this approach may not work. The second issue is 1 megabyte limits on every entity you store in data store. If you have a lot of sessions, that could be fine, but now if you put a lot of data in each session, you may run into these limits. And last but not least, you have a performance issue with this approach. It's not good, because now every time you want to look up a particular session, you're going to have to fetch this whole activity into memory to extract the session of interest. So even though when you do an index lookup, it finds this activity, you're only interested in a particular session. And you're going to have to load this in memory and to process it. And it's a performance issue, and eventually it's going to impact your quota, which is not good. So how do we address this? Well, we look at the query. Why do we join in the first place? We join in the first place because of this name property. So we're going to denormalize this, and we're going to replicate the name property at the session level. By doing this, we don't have any exploding indices issue because we don't have a list we have to index. We don't have the 1 megabyte limit because now we can do an index lookup on a particular session of interest. This session contains all the information we can index, which is date, location, and name. And finally, no performance issue because we look up only one session. Now, I can see some eyebrows raising, and what is it like? We just denormalize data, and that's it, it's going to work? No, it comes with trade-offs. And it's not trivial. Imagine you have one activity with 1,000 sessions. Now, you need to take care of the relational integrity at the application level, because your backend is not going to do it for you. This is not straightforward. How do you update this name on 1,000 or 10,000 entities at the same time? It's a long-running process, and this leads us to our second challenge, which is long-running computation. Let's start by describing what do we put in this long-running computation problem. Well, definitely, everything which doesn't fit 30 seconds on App Engine will fall into that category. But we want to put more than this. Everything which is going to impact the user experience, 500 milliseconds, 1 second, 2 seconds, we're going to consider this as long-running computation, and we don't want the user to see this happening when they interact with our websites. So we're going to push the burden of the work to back-end processes, like calendar updates. That's a call to an external API. When you do this in your enterprise, maybe you want to modify Microsoft Outlook. Maybe it's going to take 2 seconds. You want to push this in the back-end. How do we push this? We use tasks, but we use a special attribute, which is a transactional option when you unqueue a task. Say someone signs up on the website for a class, Python 101. We have to update their calendar, but we want to update the calendar if and only if we're 100% sure that the transaction that the user is doing is going to commit properly. So the way we do this is we start a transaction, then we unqueue a task with this transactional flag, and only when the transaction commits will this task be deferred in the background. And to do this, there's a very nice API in Python that is not well advertised, and it's called the deferred API. Basically, you can defer any method call without having to write a specific handler for it. So as a developer, this is very convenient. So now you're going to have all those tasks running in the background, and they may contain and raise for the same resources. That is going to maybe slow the throughput of your system because you're going to have contention between all those tasks. So one thing which is very useful is to chain those tasks. And to chain tasks, you can leverage cron jobs very easily. Let's look at our last challenge, high-performance transactional workflows. Take an example, Google I/O. We have a limit 5,000 seats available. We send a notification to millions of people at the same time. Now, at any given time, dozens of people are going to try to register for Google I/O at the same time. How do we make sure that we have this limit of 5,000, and every time someone signs up, we're going to be able to say yes or no? The way to do this is by having a transaction on this information. On App Engine, the way you do this is by leveraging entity groups. It's basically the way to group entities so that you can leverage a transaction when you work on those entities. In our sample, we have the activities, the session, and the fact that the user is signing up for a particular session in the same entity group. So when the user goes on the website and signs up, we start a transaction on this group. We look up how many users do we have right now, and then we can give an answer, yes, you are below the limit, you're going to be enrolled, or you're going to be waitlisted. Now, this is a natural approach on App Engine. But now, every sign-up becomes a transaction on a particular entity. And you cannot get a lot of transactions on the same entity at any given time. Basically, you're going to get 1 to 10, depending on what your application does. And 1 to 10 is just too slow for us. Think about it, like 12 users come at the same time, try to sign up. Some of them are going to get timeouts or 10-second delay. That's not an acceptable user experience. How do we improve this? Well, why do we have this bottleneck to start with? That's because we add the enrollment in the same entity group at the activity and the session. The enrollment is where we have thousands of users contending for the same resources. So we're going to break this apart, and we're going to take the enrollment out of the entity group. Now, if you're still following, there's reason to be concerned now. How do we make sure that we have those transactional semantics now that we remove the enrollment from this entity group? Well, the way we work around this is by constructing our application in a certain way so that we're going to leverage a Memcache API that some of you may know. It's called increment and decrement. And what's interesting about this particular API is that it has atomic semantics. So at any given time, there's only going to be one process which can access this. So how do we use this? Well, we have a counter in Memcache, which is going to keep track of how many people do I have signed up for that particular course at any given time. Every time someone signs up, I increment this counter. And I can check if it's below the limit, it's OK. If it's over the limit, I'm going to waitlist the user. Now, this is a cache, and like every other cache, whatever you put inside it can be evicted at any given time. And when your counter drops out from this cache, you need to rebuild it. And this is where things get interesting. How do you rebuild this cache? Well, if you want to be exact, you need to take this big, giant lock on the activity, the session, and the user enrollment information to be able to count the exact number of people who have signed up at that particular moment of time. And you need to have this lock because you don't want someone else to sign up while you're counting how many people signed up so far. But if we take this giant lock, we're back to square one. We have this limit of 1 to 10 per second. And we don't want this limit. So the way we're going to construct this counter is by being conservative. When we count the number of people who are enrolled at any given time, we don't want the exact count. Really what we want is a conservative count. And the way we construct this count, now when someone signs up, we're going to say, all right, you have a session with 10 people enrolled, and your limit is 10 for this session. And we're going to have to waitlist 2. But it could be that we think this counter is 10, even though there's really 9 people enrolled at that time. Because when we construct it, we're conservative. So in most cases, the user experience online is going to be good. We're going to be able to give approximately a good response for the counter, and then the people are going to be enrolled. In those very edge cases, some people are going to be waitlisted, even though really they could have been enrolled. But that's OK, because we have a backend process which offline is going to correct those answers. It's going to do an exact count by taking this big giant log on everything, the activities, the session, and the users, and it will either confirm or deny the response that the user got online. And this backend process can proceed at its own pace, 1 to 10 per second. That's fine. What we care about is the user experience online, which is going to be good. So what does this user experience look like in terms of performance? This is a profiling of a user signing up for a class online. There's about 15 RPC calls here, but the one which is of interest is the Memcache API call. The Memcache increment is taking 8 milliseconds. And that's a conservative approach, but let's say, all right, 8, 10 milliseconds. That's, if you do the math, about 100 plus writes per second, 100 plus sign up for an activity. 100 plus sign up for one single activity, like Google I/O. But you're an app engine, right? You don't have only one activity. You may have 10, 100, 1,000, billions. The underlying data store supports it. So think about it. 1,000 classes, 1,000 courses, 100 plus sign up per second for each one of them. That's 100,000 signed up per second in a transactional workflow. Now let's take a step back and see what we just did. We took a schema, relational schema, the one you're very familiar with. We analyzed the type of queries that our system does, and we made a small denormalization, not too complex. And then we leverage an existing API, which has atomic semantics. And we come up with a system which supports 100,000 plus transactions per second. Now that's pretty good. As an application developer, I didn't have to care about tuning my JVM, how much memory do I have, what's my failover policy, how do I deal with all those things. Usually you spend months working on those things. I didn't have to tune the application. And I get that kind of scalability. Even if that doesn't make you feel good, it's going to make feel good your CIO, because you don't have to provision any machines here. This application runs when it needs to run. And yesterday, I took a look at our internal deployment of Cloud Course. And we have 20,000 employees in Google. We have about 1,000 signs up every day on classes on this system. And we are still running below the free quota. So take an application like this, deploy it on in your organization, and it comes for free. No maintenance, no strings attached. So let's see what we just went over. Denormalization trade-offs. Again, don't be afraid of denormalization. Don't denormalize everything. You have to look at the type of queries that you make. And maybe you're not going to have to denormalize any of your data. Asynchronous processing. We went over this with AppReduce, Techstop Online, Cloud Course. You want to differ in the background as much as possible when deploying on App Engine. And finally, we've seen how we can leverage some advanced APIs to build a high-performance transactional system. So with that said, I'm going to turn it over to Ben with some interesting news.
All right. Thanks, Irwin. So speaking of Cloud Course, we have an announcement to make, which is that Cloud Course is available as open source for you all today. There's the URL on the screen. You can download it, install an App Engine, run it for your organization right now. It's exactly the same code that we're running inside Google, available to you today. There's going to be a posting on the Google open source blog about this, theoretically in about 9 minutes, so we can share this with the world. And as Irwin said, even a company the size of Google can run this with really, really little impact on the bottom line. If you're not a CIO, go back and tell your CIO. They might be kind of happy to hear about this. Now, it is our intent, it is our aspiration to follow exactly the same open sourcing policy with Techstop Online and AppReduce. But the reality of it is that we're not as far down the path with those two apps as we are with this one. In the case of AppReduce, we have the source code and the design documents for the daemon that sits in front of SMS or SCCM are available right now. And we've got some general, for Techstop Online, we have that. And we have I was right after produced the first time. Oh, coffee gave out on me. And then some design docs for AppReduce are available as well, and hopefully we'll have some announcements about Techstop Online coming soon. Finally, we've got the engineers who built these apps are in the App Engine sandbox, and they'll be more than happy to demo these or other applications that we use to run Google on Google's cloud technologies for all of you today or tomorrow. So please stop by, get a demo, ask us questions if there's something you want to ask us one-on-one. And now I think we'll cut over to Q&A. Let's flip over to the moderator. And we do have T-shirts that we're giving out. If you want to ask a question live, you can definitely get a T-shirt. Let's get the T-shirt artillery team ready.
One thing, please, if you can, make use of the microphones in the aisles so that we'll be able to capture your questions for posterity.
So I should add that we have a bunch of our friends from the App Engine team are here to help answer questions, since we anticipated a bunch of questions might be more App Engine or SDC-ish than just about what we do here at Google. So here we are. All right, T-shirt number 1. Okay. How many other Google teams have a T-shirt slingshot? Okay. All right, so the first question. You all signed a release when you joined. Okay. Running a 250 gig database for a well-known association, think minty chocolate cookies, not sure we could entirely get away from our SQL backend. Do you foresee any ability to replicate in and out of App Engine with such a large database? Sean.
I guess I'll take this one. So there's a couple of issues on...
Introduce yourself, Sean.
Oh, yeah. Sorry, I'm Sean Lynch. I'm the App Engine product manager. So there's a couple of issues sort of woven into the same question here. In terms of size of database, 250 gigabytes is fine on data stores that exist today. We have customers that are using databases substantially larger than that. The SQL piece, as you saw in today's keynote, is something that we're excited to announce and that's coming. So you will be able to do, it wasn't sort of mentioned in today's talks because they're not using it either yet, but that's something that we hope that people will have available to them in the near future. The replicated part, that's a little bit more interesting. I think it's one that we have to talk about, especially if there's a lot of interest in it. But at the moment, I don't think that's specific on the roadmap.
Okay, so let's go to a live question here in the room.
You want to talk about? There is, as a pitch for one of the other tech talks we have later in today, there is the bulk loader API. And we have a new version of that we released this morning. So we'll be going over that in the later session as well. Matt Blaine's actually going to be teaching that one. You can be used to accomplish that.
Okay, so live questions in the room. Sir.
Yep, hi. I don't know much about the secure data connector. I was wondering if you can give a little more background on that. Does that run over HTTPS as like a transport? And also, is the cloud course actually using secure data connector?
So
I start with Cloud Course. Cloud Course internally is using the Secure Data Connector to perform services like search, or we also synchronize our Cloud Course data with some other internal databases. To do this, yes, internally we do use Cloud Course. And in Cloud Course, you'll see on the open source blog, basically, you can plug your own implementation of different services like the search service, the user information services to use in your own enterprise, and you can plug it with SDC.
Great, thank you.
So I'll quickly explain the basics of
Introduce yourself, my friend.
Oh, sorry. I'm David Primer. I was an engineer on Secure Data Connector. Secure Data Connector is basically a technology that allows Google to reach inside of your firewall. And it does that by providing an agent that you run in your network, and that agent connects back to Google and creates a tunnel. You don't have to actually open up any ports on your firewall because the initial connection is outbound by the agent. And Google can then use that tunnel that's been created to make requests, and the requests actually originate as if they were on your internal network. They use the DNS of the machine that runs the agent, and it runs over HTTP and HTTPS.
Watch out for the friendly fire. All right, so another live question, and then we'll hit the question on the moderator after that. Sir.
Sure. So we have about 850 gigs of files that we store as just files in a file system right now. Would there be any facility within App Engine to store things like that are books, just binary data in that quantity, or would we use the secure data connector and host it on our own network? Or?
So one of the recent additions to the App Engine platform was the Blob Store API, and it's more designed for hosting things that are just arbitrary chunks of data like books or anything that is bigger than the 1 megabyte limit, so you don't have to shard it, things like that.
What kind of size limits exist for that?
So it was 50 megabytes when we originally launched it. Today we raised it up to 2 gigs.
Total for the whole index? Total for
no, that's per file is 2 gigs.
Oh, excellent. Okay,
Yeah.
Thank you.
Okay, for those of you who got t-shirts, by the way, I should mention, if it's not your size, come find Tim in the corner afterwards and he'll swap out for one that is your size. Now let's go to a question that appeared on the moderator. I think this is another one for Sean, actually. How does App Engine address government data concerns, specifically HIPAA compliance and ownership concerns where data is stored in the cloud and not on government servers?
Sure, I'll go ahead and take this one. It's a tough question. There are a lot of different certifications, and some of the certifications are really stringent ones. For App Engine, for the App Engine product as it is today, and for the App Engine business product, we are pursuing getting these certifications for our data centers. They take a long time to get. We are working on them. So I think the best that I can tell you right now is we not only know about it, but we are working on it, and we're trying to get that certification so you can have that level of confidence. Or if it's something that's required by your employer, do something for it. The other thing they can also tell you is there is a published document that we have between Google App Engine and Google Apps, which tells you about some of the security policies and how we run our data centers and how we protect data. I think it's a great doc. It's sort of it's 4 or 5 pages long, but it goes into depth on just how we run our data centers, how we control who has access to what, and all the procedures that we do. So I think that's a great thing to read or a great thing to pass on to other people you might work with if they have concerns about Google.
Okay, great. So let's take another live question.
I couldn't help notice that your examples all use the Python flavor of the App Engine. Are you guys sending a secret message to us that have deployed Java?
Oh, no. Oh, great question. Absolutely not. So it so happens that the goal of the presentation was for us to show you all problems that we thought related as closely as possible to problems you might have as you thought about trying to get your feet wet in App Engine. And a lot of that has to do with how you talk back to services that are inside your company. It just so happens that the apps that we selected that we thought were great exemplars of solving that kind of problem were in Python. But in fact, we have an application that we use for doing feedback on interview candidates called Hire No Hire, which is a Java GWT App Engine app that talks back to our applicant tracking system. And Matt, who's the author of that, is here today he'll be in the sandbox if you wanted to talk about our experience with the Java GWT App Engine environment as well. They're both great. I think it really has to do with the skills that you have and want to have in your environment, right? We're big fans of both. Another live question.
First there was Python, and then I guess Java. Are there any plans for future languages?
I know of no plan for a COBOL App Engine, but
So at the moment, there's nothing official that we can say. If there's other languages you're looking for, definitely take a look at some of the open source projects out there to get other languages running on the JVM. I know that we have some JRuby guys here today that have been really successful. There's guys actually, Clojure's actually in our sandbox, I believe. So there's a lot of people doing a lot of really cool things with other languages just on top of the JVM.
Why don't we take another live question, sir?
Okay, thanks. One of the things that's talked about is it just works. People who deploy their applications typically monitor them. IT managers need to monitor their equipment, network storage applications. How do you monitor that within Google for yourself so that you don't get the call that says it's down and nobody else fixed it? And what do you provide to people that use App Engine to make that possible for them, or some parts of that?
So one thing, and this has to do with the question that's up on the moderator as well, that we should make clear, is that we try very hard not to kind of go around the back door and take advantage of the fact that we're all in the same company. But when it comes to how Google runs itself, we want to treat ourselves like a customer. Obviously, the people who work on App Engine and the people who work on these apps are colleagues and have collegial relationships and so on. But it's really important to me, for my organization, and to Kevin and David and Vic, that we treat this as a model provider-customer relationship, right? And that we learn about App Engine for Business is brand new. We just launched it today. The goal is that we do this so we learn about how to make these business offerings better, right? If we just kind of went behind the door and took advantage of stuff that was only available to us, we'd be in real trouble, right? Because we wouldn't be doing anything to make these offerings better. So I don't know if that answers your question. The question was specifically about, hey, we use the Google dashboard, right? So, you know, and we could talk more about the services that are coming online in App Engine for Business that'll support you and all, but we try very hard to do exactly the same sorts of things that you all would do as well. You know, it's because the products are evolving, how we do that evolves too, but the goal is not to cheat. Are we about to get the boot? Oh, but the clock is going up, not down. I thought that meant, okay, all right. So, what? So we'll be in the sandbox if you've got more questions. I think we are getting the yank. So please come by, ask us questions. Thank you all.